Happy Friday! Today we're talking about the scientific method, and at this point in the year this is mostly just review, especially since we've been talking about this year after year since you were in at least third grade. So this should all be old information, but just hopefully as a refresher. And when we come back from Labor Day weekend on Tuesday, please be prepared for a quiz on this information along with variables and graphing. So this past week, all of you have been doing different types of experiments to investigate questions involving how manipulating variables would affect the swing time of a pendulum. And so you went through the process of the scientific method in order to test predictions that you made with your group. Another term you might hear is called scientific inquiry, and that just simply means that you ask a question and you go through the process of making observations and measurements to test your hypothesis when you're trying to answer your question. So this is what the scientists truly go through in real lab situations as they're trying to figure out how to find solutions to the problems that we face every day. So we have some general steps in the scientific method that we typically will go through anytime we do an experiment in class or in real life. But I do want to point out that the method does not always follow the step-by-step neat little plan. But this is just kind of the basis for how people will typically do an experiment. So the first step is to ask a question. The second step would be to form a hypothesis. After that, you go through the process of designing and conducting an experiment. Then from there, you would analyze the data. Usually you'd make a graph, so you'd be able to have a visual representation of the information. And then from there, you can draw a conclusion. So we're going to go into some more detail on how to do all these things through the next few slides. And this is going to greatly help you in the future this year as we all set out to do our own science experiments for the spring. So step one, asking a question. Just a few tips on when you're doing this on your own. Here are some ideas for you to keep in mind. First of all, you want to choose something that you're curious about. This way you'll be invested in the lab and you'll actually care about the outcome. You also want to choose questions that you don't know the answer to, because if you already know what's going to happen at the end, there's not much of a point in going through a procedure to figure out the answer. It's not really fun. You also want to choose questions that can be tested through observations or experiments, and this means that you need to be able to make some type of measurement and go through repeated trials. So for example, one of the questions that one of the groups this week had to conquer was, how will the length of a string affect the time of its swing? So from there, you'd have to form a hypothesis, which is typically step 2. And just to review, a hypothesis is a prediction or an educated guess. So if you don't really know enough about the information to make a really strong prediction, you want to at least take what you already know about the situation and apply that to a guess. That's what it means to make an educated guess. You want to make this in the form of a statement as an answer to the question that you had in step 1. And most of the time you'll see this in the form of an if-then statement. So for example, some of you had said this week that if you increase the length of the string, then it would increase the time it takes to swing back and forth. So you want to be very specific in the prediction that you make and try to avoid making general statements, but you want to actually take a stand with your opinion. So once you have decided on your hypothesis, you need to design an experiment that is going to test that hypothesis by keeping all of the variables the same except for the one that you want to test. That way, as you're going through the experiment, you can check the other variables and see what's being affected by what you did. It's always a great idea to do repeated trials, so that way you can compare the data that you're getting throughout the whole procedure and make sure that it is accurate. That means that it kind of lines up with what you're getting in some of the other trials. Make sure that you're doing your measurements correctly. As you're doing precise measurements, you need to try your best not to make mistakes. I understand we're all human, so at some point there will be error, but we can often avoid mistakes by simply being really careful in our measurements. And so you have to be careful with the tools that you're given and be sure that you are paying very close attention to how you're using them in order to get the most accurate information. When you're collecting data, you want to put it into an organized table. That means it has the columns and rows, and it has everything labeled the way it should be. So that way, if someone comes into our classroom and doesn't know really, what's going on, you can show them the data table, and they should be able to interpret what you're doing just by looking at that chart. So our example here is just a brief summary of the procedure that the length group did in terms of having to change their 5 different lengths of string and see how long it would take for the string to swing back and forth. So if you could just take a second to read through this example and maybe even in your head compare it to what you did with your own group. This will just give you some ideas for the future for when it's your turn to do your own experiment for the science fair. Step 4, after you've gotten your data into a table, you want to analyze it. And so one of the best ways to do that is to represent it in a graph, sometimes in a picture. The idea of this is to look for trends. A trend is like a pattern. So sometimes a graph might steadily increase in the slope, or it might decrease. It might stay the same height all throughout. And so in looking at those trends, you'll be able to understand if there are any relationships that are taking place. So for example, with the length manipulation this week, by putting the information into a graph, people should have seen that it would take the longest string more time to swing 10 times back and forth than it would have for the shortest string to do that. Finally, in step 5, the last step, you draw a conclusion based on the data that you see in your graph. And so several tips for drawing a conclusion. First of all, you want to make sure that you say if your prediction was right or if it was wrong. So you want to go ahead and apply this to what you thought ahead of time. You also want to see if you can find out any explanations for your results. So see if there's a way that you can think through the process and after your observations, come up with a way to explain what happened. Then many times after you're done with the conclusion, you might wonder, okay, well, why did that happen the way it did? And many times you'll come up with new questions that could possibly lead to new experiments. One thing I want to be sure you'll understand is that it's okay for a hypothesis to be wrong. We're wrong all the time, and it's just a human thing. Not everyone's going to be right all the time. And usually that's the way we learn the most, is from when we're wrong about something, we want to know why it is the way it is. And many times we'll investigate more information about it and we'll learn more. And so this is how it works in real life with scientists in labs. And so we want to take a lesson from them. So for example, you could conclude that the longest string took the most time to swing 10 times because it had more distance to travel in the air. And so an example of a question that the group that was dealing with length was maybe they could change mass instead, and so they could come up with a question to investigate if they had more time. So just to apply this idea in a real lab, we just, again, want to remember that experimentation does not always happen in the neat steps described. It's not always necessarily in that perfect order, but those are the main parts of experiments that could show themselves in different orders depending on what the person is investigating. A lot of times in the middle of an experiment, there might be something weird that happens suddenly, and the scientist will kind of follow that path and come up with a new experiment based on that question that arises because of this odd thing that happened. And they might abandon the original experiment altogether. So I just want you to understand science is really messy, but that's part of what makes it fun. And so throughout the rest of this year, we'll be experiencing the scientific method. And if things don't always work out as neat and organized as you expect it to, don't be upset and don't be disappointed. That's just how science works. So again, please make sure you review these notes. you review your notes on variables and graphs, and be ready for a quiz when we come back on Tuesday. Hope you have a great long weekend, and I'll see you then.